Next problem is problem number 15th. For a given mechanism, the figure will be given in the problem. The force acting here is F, that is 500 Newton at an angle of 30 degree with horizontal. And then the distance OA and AB are given 250. OA is given 250 and AB is given 650 Newton. And the distance between O and B are 50 millimeter. And this angle is given from A it is 35 degree and from B it is 30 degree. Both will intersect at one point. That point is called as C. Now this figure we will solve today. First draw a horizontal line. Draw a horizontal line and then mark a point called as O. First we'll mark here O point and the angle given at that point is 60 degree. So take 60 degree from this point. So we'll take 60 degree. Then join it with a scale. With thin line, and then the distance given is 250 millimeter. If we divide it by scale 1:5, divide the scale by 1:5, the distance you will get is 25 millimeter. So take the scale, or you can divide it by divider. Take 25 millimeter. Keep at O point, then divide it. You will get A point, and then the another distance given is 50 millimeter divided by 5 is 10. So take 10 mm, and then another distance given AB, it is equal to 650 millimeter divided by 5. So around 53 will get. So we'll take 1:10 scale. The distance is 250 divided by that is 25 millimeter. I have taken 1:10 scale I have used here. So 251 distance OA, it is equal to divided by 10, it is equal to 25 millimeter. And another distance given is 650 mm. So divided by 10, so 65 millimeter. So take 65 mm. Then keeping at A point, cut this 10 mm line. So you will get the distance wherever it intersect, join with A. Here you will get point B and draw a piston here. This is a B point and link 4. Then from here you have to take 30 degree. From this you have to take 30 degree. From A you have to take 35. Then just extend, both will intersect at one point. And then extend this point for 30 degree. It will intersect at this point. So that point is called as C. Now we will transfer this horizontal line, exactly at C point, and then we'll take 30 degree from that point. We'll join it. Then that force is called as F. It is equal to 500 Newton, and angle is 30 degree. This angle is 35 degree. This angle is 30 degree. This is the third link. Second link, torque T2 is acting. This is first link. This is also first link, and this is the fourth link. You can call it as fourth link here, right here. So this is the construction of given problem. Now we have to draw the three body diagram of all the three links. So this completely ACB is one link. Now we'll draw parallel to second link. So we'll draw parallel to second link, and then another force acting. This is the link we'll draw here. So first one force acting, because of it is a two force member, one force acting is at the contact, another force acting perpendicular. Because of two force member, one force acting is 1 on 4, another force acting is 3 on 4. So F1, 4, 3, 4 are equal and opposite at this point. This is the B and fourth link. Now this is the second link T2, and this is second link, and the distance is 25. Just cut 25 millimeter for that. So we'll cut at this point, keeping this point, we'll cut here. So we'll get O point, A point. This is not required. Now the force acting at these points are 1 on 2, and for this point the force acting is third on 2. Third will be acting on second link. Now force acting on 1 on 4, here third link on fourth link. It is not parallel to this because the fourth link is a two force member, hence one force is always acting perpendicular to this contact, and another force will be always parallel, opposite, equal and opposite to F14, F34 because of two force member. Now once again you have to draw this. So we'll draw here. $65mm I have drawn, and then we'll take angle. Once again you have to construct the same. From this point it is 30 degree, and from this point it is 35 degree. Wherever both will intersect, you will get C point. We'll draw from this point. Next from this point, and then wherever it intersects, you will get C point. This is A point, this is B point, this is third link, and this angle is 35 degree, and this angle is 30 degree. Then the force acting, for that we will transfer this horizontal line. This line will transfer at this point. Then we'll take 30 degree. From C point you have to take the 30 degree. Then just join this. So we'll remove this line, extra line. Then for this point will be joined for C. Then this angle is 30 degree. This is the force F acting. Now the force acting at this point is F4 on 3 at this point, second link on third link. So F23 is acting here. Now we know the line of action of F34. This F34 is equal and opposite to F43. Hence perpendicular line you can draw here. or you can transfer here a line and extend this line till it intersect the F force, and then wherever it intersect, join this A point. Wherever it will intersect, join the A point. So some distance will get. This is the line of action of F23, and this is the line of action of F43. Now the known force is, this is the F force. This is the known force. It is having 500 Newton. Now convert that into scale. Now 200 Newton is equal to, now 500 Newton. So we'll convert 100 Newton equal to 1 centimeter, means 500 Newton is equal to 5 centimeter. Now parallel to this F force, keep it parallel with F, because that is very important. Parallel to F force, draw 5 centimeter. Draw 5 centimeter because of direction OA. This is 5 centimeter, or you can call it as 500 Newton F. Now from O you can transfer one force and another force, F23. This F43 will transfer from this A point parallel to F43. I have transferred at O point, or you can transfer at A also. Now we'll transfer this force, that is F23 force, parallel to F23 from another end. From A point we'll transfer that force. So once again we'll take this distance. So it should not alter. If it alters, the error will be high. So we'll transfer this force here. Wherever it intersects, that point is called as B, and this force is F43, and this force is, below force is F23, and the distance you have to measure here for F23. You get 4.7. You will get 4.7. You can exactly see here 4.7 you will get. So F43, 4.7 multiplied by scale 100 Newton. So that is equal to 470 Newton. So F23 will get around 5. So 5, there is 0.5 multiplied by 100. So we'll get 50 Newton. This is F23, and this is this force is F43. Now I have calculated F43. Now go for second link. Before that, this force once again, or you can show here only. F43 is equal and opposite to F34, hence the direction, once F force is known, another direction will be in cyclic order. F43 is upward, F34 is downward, and it is equal to F14, but direction is opposite. Now draw this force. Second link once again you have to draw. We will draw here once again the second link, which is 25. We'll check whether it is 25 or not. So it is 30 is there, so remove half. only this point. This is torque T2. Force acting will know 3 2 and 1 2, and this point is O, this point is A. So now 3 2 is equal and opposite to 2 3. You know that the force is 2 3. This 2 3 is equal and opposite. This 2 3 is equal and opposite to 3 2. So we'll transfer at this point. The same parallel will transfer at O point, because F32 is equal and opposite to F12. Here we have calculated F23, so F23 is equal and opposite to F12, equivalent to F32. Now the perpendicular distance between two forces, that is 90 degree, will give height. So height is equal to, you can measure the height. The height is equal to 29. The scale, so height will measure it. So it is around 14.5. So we'll remove it. So 14.5 millimeter multiplied by 10. So 145 millimeter you will get height. And then torque T2 is calculated. So once again I will explain this. First you have to draw this torque parallel to this, and then F23, this is F23 is equal and opposite to F32. So both are equal and opposite. Hence the force acting at this point is upward and the force acting at this point is downward. Parallel to F23 you have to transfer at A point, and parallel to 32 you have to transfer at F12. And the force acting here is downward, because this is upward, downward, this is upward. Hence the couple acting is counterclockwise, torque acting is clockwise. And then the height you have to measure, you will get 14.5 multiplied by original K. I have taken 1:10, so 145. T2 is calculated by multiplying height into the forces which are calculated here, 470 Newton. So you will get 68.15 Newton meter clockwise.